Okay, welcome to this video, and in today's video, okay, we're going to talk about double number identities. Okay, so we are doing trigonometry series. Okay, okay, so double number identities. Is it visible? The marker. Okay, double number identities. Okay, so in a previous video we have talked about the proof of the identity cosine A minus B. Okay, it's called okay, so talking about sum of angles, identities of sum of angles. So cosine A plus B, cosine A minus B, we talked about these. Sine A plus B, sine A minus B, and also tangent A plus B, tangent A minus B, as well as cotangent A plus B, cotangent A minus B. And if you are interested in knowing that, you can watch my previous video. Okay, but in today's video we're going to talk about double number identities. So this is also immensely simple. If you know the formulas that I've mentioned in the previous video, then you can derive, okay, these formulas that we'll be talking about, okay, from them easily. So what do I mean by double number identities? Okay, so by double number identities, I mean the angle is multiplied by 2, so it means 2a. Okay, if the angle is a, then double number might be double. Okay, double of that angle is 2a, and by double number identities I mean finding sine 2a, cosine 2a, and all those ratios. So in order to find sine 2a, we can use our previous knowledge, okay, which is we know what sine A plus B is. So you're gonna just write this as sine A plus A, and I hope this looks very much familiar to you, and you can, I mean, simplify this, do this easily. So this will be what? Sine A cosine A plus again sine A cosine A. Okay, so what happens in A plus B is that here it gets switched, but as both of them are the same thing, it doesn't get switched here. Does that make sense? If you have A plus B, then this part becomes cosine A and sine B, but we have A's and B's the same thing, so it becomes this, and if you add it up, it will be 2 sine A cosine A. Okay, it means sine A plus sine 2A is 2 sine A cosine A. Okay, did you get it? Sine 2A is 2 sine A cosine A. So this is our first double number identity. Now the second one is cosine 2A. How do you derive cosine 2A? Again, easy. Cosine
A
plus A. Okay, and if you do this, it is going to be cosine squared A minus sine squared A. I'm just going to write the result because I know people can do it on your own. Okay, the derivation, where does this come from? Okay, you just have to do cosine A plus A. Okay, and follow the computation. Okay, so the result will be this: cosine squared A minus sine squared A. You can write this in different ways. You can write this thing in other ways as well. So one way might be that we write cosine squared A minus sine squared A in terms of sine only. Okay, you can write this in terms of sine only. If you write this in terms of sine only, then this will be 1 minus sine squared A minus sine squared A. How do I do this? Because there is an identity, sine squared A plus cosine squared A is equal to 1, and you can find out from that what cosine squared A is in terms of sine. This is going to be 1 minus sine squared A. This makes sense? Okay. Okay, so if you want me to show here, I can show. Sine squared A plus cosine squared A is equal to 1. We know this identity. From this we derive what cosine squared A is. This is going to be 1 minus sine squared A. You replace it with that, and you have your formula ready. This will be 1 minus 2 sine squared A. Okay, so you can write the same thing in terms of sine like this, in terms of sine only. Okay, and if you replace this in another way, meaning if you want to write in terms of cosine only, then replace sine by cosine. So it will be, by cosine counterpart. Okay, that it's, yeah, in the cosine form. So sine squared a will be 1 minus cosine squared a. Okay, and yeah, and you're going to have 2 cosine squared a minus 1 as the result if you write in terms of cosine only. Okay, so this is your next identity. Okay, so this is your next identity, that cosine 2a is cosine squared a minus sine squared a. If you want to write it in another, in another form in terms of sine, then this is 1 minus 2 sine squared a. This is also 2 cosine squared a minus 1. 3 different ways to write the same thing. Okay, where's the duster? Okay, so I hope till here it makes sense. Now we have these identities ready for us to use them in different problems. Okay, we have sine 2a, we have sine 2a, we have cosine 2a. Okay, ready for us. Okay, now it's time for tangent 2a. We're gonna figure out what tangent 2a is. Okay, so tangent 2a, we can do the same thing, use the same logic, that tangent 2a is tan a plus a, and the result that you get is 2 tangent a divided by 1 minus tan squared a. How does it, where does this come from? How it is? You can derive it. You can use what tan a plus b is into this form, into this formula, and you will get this 2 tangent a divided by 1 minus tan squared a. Okay, so this is your tangent 2a. Now, if you want to find out what cotangent 2a is, then cotangent 2a simply is going to be what? Reciprocal of this, reciprocal of tangent 2a, which will be 1 minus tan squared a divided by 2 tan a. And if you want to convert this into cotangent form, then you can replace tangent square a with 1 over cotangent square a, and the formula will be in cotangent. Okay, if you replace this tan square a with 1 over cotangent square a. Okay, and here as well. Okay, so these are your formula, new identities, respective identities here. Okay, that we wanted to derive. So tangent 2a is that, cotangent 2a is this thing. Now let's do some example problems. Okay, so let's go ahead. Let's do some example problems now. Okay, it's hard to wipe. Okay, let's do some example problems. Example 1. You want to figure out what cosine square 15 minus sine square 15 is. How can you do that? If you want to figure this out, then you can use simple logic. First of all, what do you see in here? What next step do you see?